Welcome to CEC Gurukul Lectures. I am Dr. Sangeeta Kaul from Department of Chemistry, Sri Aurobindo College, University of Delhi, and we have started with a series of lectures on green chemistry. In my last lecture, we had discussed what is the importance of green chemistry, why is green chemistry needed. So, there are certain goals of green chemistry, that is, we have to design safer chemical entities which are non-hazardous to mankind and are equally efficient or better suited. We had discussed the example of the MIC leakage, where this MIC, that is methyl isocyanate, this was a byproduct for producing a insecticide called Sevin or carbarin. Had the designing been better, the incident wouldn't have happened. Similarly, we have to attain or development of chemicals which are biodegradable and non-bioaccumulative so that they do not affect the food chain. Sustainability of natural resources is a must. So, continuous innovation is needed to solve the real world problems. So, green chemistry is an emerging field and has received wide interest because of its ability to harness innovative chemical methods to attain environmental and economic goals. And work in this field started approximately 3 decades ago, and the pioneers were P.T. Anastas and J.C. Warner. They have formulated 12 key principles. These principles, they are the basic principles of green chemistry, and we will be discussing these principles one by one. The first one being the waste prevention, then atom economy, less hazardous synthesis, energy efficiency, designing safer chemicals, and so on. There are 12 principles, and we will just go through all the 12 principles one by one, and then we will try to interlink these principles. For example, weight prevention and atom economy. We have to see that both the principles are interlinked and we get benefit out of it. So, we will start with waste prevention. The first principle. This principle is based on the saying that prevention is better than cure. Rather than treating the waste produced at a later stage, the principle advocates that it is better to prevent waste formation at the very onset of the process. Waste is production of any byproduct or material that has no use or value, and even energy cannot be harnessed or remains unutilized. The waste so generated in the process affects the environment adversely, both in short term as well as long term, and its hazard depends on the nature, quantity, toxicity and the way the waste is released into the environment. Roger Shelton has introduced a concept of E factor, also called the environmental impact factor. So, we will be discussing this factor, but before we move on, this should be clear that it is not only the quantity of waste, but also the toxicity, which is important. So, we have to consider this also. And while discussing this weight prevention or this principle, of course, we will apply this to chemical equations and do a study, but at the same time, I will try to link waste prevention to waste management in our daily life as well. The concept of E factor is now widely accepted as a benchmark. E factor is used to quantify the waste produced per kilogram of the final product. This is used as a measuring value for grading environmental acceptability of any manufacturing process. Many innovative and new process methods have been developed or are being developed so as to get a lower value of E factor. Waste can be used as a new raw material for another chemical process. For example, we know that production of biofuels from organic waste, as it reduces the adverse impact of the unutilized waste to the environment. A concept of zero waste is designing and managing processes and products to avoid and eliminate the volume of waste produced and to conserve and recover the resources without harming the environment in any way. By implementing the strategies of zero waste, elimination of discharge to land, water or air can be achieved and ecosystem as a whole will be benefited. Unwanted materials of no use are generated in almost all activities of mankind and are to be disposed of, as these are considered as waste. In daily life, vegetable peelings, then your fruit cores or maybe skin and fat trimmed of meat or fish, etc., then your bottled ingredients, cans, etc., they all generate waste which need to be segregated and disposed of with a scientific approach. As I said, I'll be linking the waste produced or the waste management in our daily life and with the chemical equations as well. Now, a waste hierarchy has been developed by scientists which can be applied to help reduce, reuse or recycle the solid waste. A new concept of zero waste has come up and has gained phenomenal response across the globe over the past 2 decades. The term became viral on internet and has gained momentum. The environmentalists became vocal about the concept and started advocating the concept of zero waste or no waste. Cradle to grave is a model where materials begin with the extraction of resources and after production and manufacture end up in grave. So chemists are working on the concept of zero waste and to reduce waste. Green chemists have incorporated zero waste concept as one of the 12 principles of green chemistry. Scientists have worked on the principles of 3 R's, that is reduction, reuse and recycling, along with the recovery and disposal, and the favored options have been charted out on the waste hierarchy to be followed. We will be discussing the waste hierarchy also. So, the first in the queue is waste reduction. It is at the top of the hierarchy as it is the most effective way to limit the health and environmental impacts of the waste, as to create no waste is the best way to reduce waste. Waste reduction is important at household level in a day-to-day basis also. It can be achieved by educating householders through house visits, by experts and by educating people in communities. In many cities, it has resulted in behavioral changes among community members. Target of waste reduction has been taken up by NGOs and private sector enterprises and with the support of government agencies, of course, and educational campaigns are undertaken to raise awareness of the economic incentives and also to reduce the stigma attached to working with waste. In any industry, to make a new product, material and energy is the prerequisite. Raw material after extraction from earth are processed and after manufacturing the product is packaged and transported to be sold. All these stages produce solid waste or maybe liquid or air pollutants, liquid waste or air pollutants, and green chemists are finding out and are working on new innovative processes that can be adopted to effectively reduce the waste and pollutants in process to reduce the waste and pollutants and in this process reduce pollution as a whole. This is to save the natural resources, protect the environment and economically effective process. Some of the simpler ways to reduce waste are using less packaging material, buying in bulk, use of reusable rather than disposable items. Example, rechargeable cells is a good example, and refillable ink pens. Use of own shopping bags, preferably made of cloth or maybe recycled material. So these things we can do in our day-to-day life. The second option in waste hierarchy is waste reuse. The process of using a waste product without any change in its original nature and shape is termed as waste reuse. We can give example here of bottles, old cloths, books are easily reusable. Then reuse is also held for disadvantaged people who cannot afford to buy new goods. Reuse centers are created at local levels which collect and distribute reusable goods. This also provides community benefits as long-term unemployed and disabled people can be trained for the job. By reusing products rather than creating new products, burden on economy is lessened as there is reduction in raw material and products and raw material product import also. So reusing lowers the input of water, energy and other resources, and thus is an environmental friendly approach. Recycling waste incorporates reprocessing of the material before being used to make new products. Activities involved in reprocessing can impact health and environment of people associated with the activity. It is to be weighed whether these impacts are lower or the impact if the new product or new raw material are manufactured, that is lower. That is, if we are recycling some waste, we have to know that the new product that is being formed from this recycled waste, is that going to be used somewhere, or it is again going in landfills and getting accumulated, or so on. That is, we have to weigh the options, that what is the better thing to do. It is important to find a market for the new product that is manufactured from the waste. Otherwise, the process will not be economically viable and sustainable. The recycling process to be undertaken depends on the type of waste. So, it is important to segregate the waste. Segregated waste can be put to different uses. For example, waste paper can be pulped and new paper for printing and packaging obtained. Waste metals can be melted and new sheets and ribbons obtained. Plastic bottles can be ground and ropes and plastic coatings for various purposes obtained. But then to have the use of that item is the basis, or that should be known before we start with the process. Also, organic waste, which include the waste obtained from kitchen and all biodegradable waste, can be used to get compost, and composting can be done at a commercial level as well as in small scale. This helps not only in reduction of waste but also in improving the quality of soil, and added advantages that chemical fertilizer use can be lessened. This can be taken up at the local levels, like in our institution, in our college, we have got a compost pit made, and wherein we put in all the green waste that we get from college canteen, or maybe the green leaves which have dried up. So we just collect them and we put them in that pit, which gets wherein the aerobic changes take place, and finally we get compost out of it. For composting, ideally 3 parts of brown waste is mixed with 1 part of green waste. This is ideally, it should be done this way. Brown waste can be hay, it can be straw, it can be eggshells or maybe woody material, etc. And green waste is animal waste, food waste or dried leaves, grass, etc. Composting is usually done in a pile. It is an aerobic process and hence needs to be turned upside down a number of times so that oxygen is mixed thoroughly. And once the composting process is complete, the raw materials cannot be identified. That is, the raw materials, whether they were dried leaves or they were food waste, you cannot identify. They have changed totally into a new product, and that is your compost. Recovery is the 4th option in waste hierarchy. Here some use for the waste is found so that some value can be recovered. Usually this is attained by using the waste as a source of energy. In developed countries, energy is recovered from waste on a large scale. For this, high technology incineration plants are used. It requires highly developed infrastructure, a reliable source of waste, good transportation facility, a power distribution grid, etc. But here we are talking about recovery on a large scale from the waste. This can be done on a smaller scale too. Biogas production is undertaken on large scale as well as small scale from organic biodegradable waste. Biogas production makes use of anaerobic digestion process. Biogas reduces the use of food fuel. It is a clean fuel. It does not pollute the environment. It has a good calorific value, and additional benefit is that it contributes in the reduction of greenhouse gases. Again, here I would like to mention that on a small scale this can be easily attained in colleges, schools, etc. We can have a biogas plant wherein we can put in the waste that is obtained from school or college canteen. We can put in our dried leaves and finally the anaerobic bacteria, and the tank, when the biogas is produced, it lifts up. This gas is collected and through pipeline it can be put in for small uses in maybe your staff room canteen or in chemistry labs, wherein this gas can also be used. In this process, sludge is obtained as a byproduct which can be used as a fertilizer, and it is known to improve the soil quality. To operate a biogas plant, equipment and expertise is needed. Now we have talked about the waste hierarchy, and thus we can say that the waste hierarchy is a guide to select the best option and strategy to dispose of waste. The management intervention can be undertaken keeping energy and environmental benefits in mind. This involves chemists in designing processes and products that will reduce or totally eliminate the waste formed that would otherwise be needed to be thrown away later. For achieving the target of zero waste, commitment is needed from industrialists and laws are needed to be framed by the government agencies, and compulsory audit for various manufacturing units should be undertaken. The free tool for the same has been provided by some agencies, and US Environmental Protection Agency has come up with a good tool. It can be included as one of the good business practices. So as we said that we are talking about the waste prevention here, and waste prevention is the first principle of the green chemistry. So waste prevention is better than waste cleanup. So process is to be structured or designed in a way that amount of waste produced is less as it can be. Otherwise, time, energy and money is spent in cleanup afterwards, and hazardous waste can cause health and environmental issues. Green chemists have to work aiming to judiciously use Earth's resources to achieve sustainability. Social sustainability and economic sustainability also. We have to talk about sustainability on three levels: environmental sustainability, social sustainability and economic sustainability. So when all these three are taken care of, we say that this is the resource efficiency. So the term resource efficiency has come in, and green chemists are working to increase the resource efficiency. Because Earth's resources are limited, so they should be used in a manner to get maximum output and cause no harm to environment. Now the term E factor or environmental factor, this term is used as a measurement of amount of waste created in a chemical process. E factor is equal to mass of the waste produced upon total mass of the products. Now how to calculate this, we'll just see. In this process, for the manufacture of Z salt, we see that there are three reactants giving us the desired product, that is your Z salt. So we have to add up the quantity of the reactants, and we know the quantity of product that is being formed. When we subtract the two, we will get the amount of the waste produced. So once we know the amount of the waste produced, when we divide it by the total mass of the product, that the desired product was this much amount and the waste produced is this much. So when we divide the two, what we get is your E factor or the environmental factor for a reaction. But like in this process, as you will see that we have not taken the catalyst into account. The weight of catalyst is not taken into account. Of course, it is not involved in the reaction, but for the production of this catalyst, again some chemical process must have taken place and some byproduct or some waste would have been formed. So actually, to calculate the E product, we have to add up the two. So this concept of E factor, this can be also well understood by example of the synthesis of an organic compound known as fluoroglucinol. This fluoroglucinol is used in the synthesis of pharmaceuticals and explosives. In 1980s, a manufacturing unit was set up in Oceandino, and this was finally shut down. The reason was the waste disposal problem. The cost of waste disposal was getting similar to the selling price of the product. The process was generating almost 40 kilograms of waste for every 1 kilogram of the fluoroglucinol produced. That is, the cost of disposal was getting very high and it was almost similar to the selling price of the product. So we have to keep that in mind. Another thing is that a higher E factor would mean more waste and consequently greater negative environmental impact. So for an ideal reaction, the ideal key factor would be 0. 0 is the key factor, it is best suited for the environment. And more the value of E factor, the environment is getting affected. So put quite simply, it is kilograms in my weight of raw material in kilograms to weight of kilograms of the desired product divided by kilograms of the product out. Or it can be easily calculated in a big factory by the knowledge of the number of tons of raw materials purchased and the number of tons of products sold for a particular product at a particular production site or even for the whole company. The E factor takes only the mass of the waste generated into account. However, it is important that the environmental impact of the waste is not just its amount, it is also the nature of the waste which we must consider. For example, if a factory is getting 1 kilogram of sodium chloride, that is your common salt, as a waste, and another factory is getting 1 kilogram of chromium salt as a waste, we cannot equate the two. Of course, the one that is more toxic will harm the environment more. Hence, a new term has come up, and that is environmental quotient has been introduced. This is, we multiply the E factor with an arbitrarily assigned unfriendliness quotient Q. So, apart from E factor, now EQ factor is also studied. Like I said that we have to arbitrarily assign a Q value. Supposing we assign value 1 to NaCl. So for a heavy metal salt, maybe for chromium it will be 100 or 1000 or so on. So it is important that not only qualitative assessment but quantitative assessment is also done of the waste. It is also worth noting that Q for a particular substance can be both volume dependent and influenced by location of the product facility. Now there is another term which we must study, that is waste valorization. Waste valorization is the conversion of waste to energy, and it can be achieved by reuse, recycling or even composting waste matter to get chemical entities or fuels. So this waste valorization we will take in the next lecture. We will stop here, and I will just show you the references. For further study, you can go through these references. Thank you.